Hi everybody, we are moving on to learning targets 3 through 8. So this one video is going to cover all of those learning targets, which I know seems overwhelming, but again, it's just little bits and pieces, and I just broke them up into that so that we didn't have one huge learning target. So here we go. A rigid motion, you've been learning about them. They're any transformation, translation, or rotation, or reflection, such that the distance of the points is preserved. So if I do any of these three, so whether I reflect it, I rotate it, or I translate it, look at those graphics, the size stays the same. However, if I were to dilate it, it doesn't keep it the same size, so that's why it is not a rigid motion. All right, so let's talk about isometries and direct isometries. All of these are rigid motions. Remember, the only difference between an isometry and a direct isometry are the orientations. So all of them are isometries, but only two of them, rotation and translation, are direct isometries because, again, reflection does not preserve orientation. That's a big thing to remember. It does not preserve orientation. So let's talk about each of these. So if I were finding the image of a translation, I literally just add or subtract. So if I see this capital T that stands for translation, the two little numbers are talking about the horizontal shift and the vertical shift, or the X and the Y values. So this is saying add 3 to your X, so move to the right 3, and add 4 to the Y, so move up 4. That's essentially what you are doing. In your coordinates, it's going to, affect it that way. So on the other side, we're subtracting 3. So that's telling you to move to the left 3. And then you're going down 4. So the negative doesn't necessarily mean that it's a negative distance. It's telling you a direction to go in. So to quickly do those, you literally just add. So for number 1, you would do -5 plus 3, 2 plus -4, which is the same thing as 2 minus 4, and you get -2, -2. In number 2, we would add 2 to the X value, subtract 1 from the Y value. So we would get -3 plus 2, and we would get 4 minus 1. 4 minus -1. No, I was right, 4 minus 1. So this should be 3. Sorry. Fix that. That should be a 3. My bad. In number 3, we have P moving to P prime. So they're telling us 3 went to 6, 5 went to 1. So let's think about that. What is happening? What is the translation that's occurring there? I'm going up 3 and down 4. So then what would the coordinates of this other point be if I did the same thing? So I would add 3 and go down 4. It's that simple. In number 4, what is the image of the point under this translation? So I'm going to do 3 minus 2, and -4 isn't going to move. It's going 0 distance, and I get 1 -4. That's it for translations. It's that easy. With a rotation, you are going to work on using your paper for this. Some of you are going to get the rules. So, sorry, I'm going too fast. If you start with a point, and then you turn your paper to the left, because you always rotate to the left, you're going to have this coordinate. So notice how the coordinate 3, 2 is now 3, -2 is now 2, 3. And then when you flip it to the left again, that's a rotation of 180. You're now at -3, +2. So whenever you do a rotation of 90, that will always happen. You're always going to switch your coordinates, so X becomes Y, Y becomes X, and whatever was your Y value, your sign will change. So if it was positive, it will become negative. If it was negative, it will become positive. This is one of the activities you did in the stations. With a rotation of 180, your signs will always change. And then with a rotation of 270, if I were to flip that one more time to the left, this pattern would always take place. They would switch places, and then whatever was the X value would change its sign. So let's do a few examples of that. So what are the coordinates of A prime after a rotation of 90? So I would plot A to start, and then if you are a doer, you're going to make a little left arrow in the top left of your paper to make sure that you are in fact going counterclockwise, because we always go to the left, and you are going to turn your paper once to the left. So now you're going to look at your orientation like this. So you are at -4, -3. Boom. If you were a rule person, you would have just switched them and negated that Y value to start with. Moving on to number 2, I have the point here. It's going to be rotated 180 about the origin in a clockwise direction. So we're going to do the coordinates of the image. So I'm going to turn it once, turn it twice for 180, and then I'm at +2, -1. So those are my new coordinates. It's that easy. You're literally just turning your paper. So 270, it would be 1, 2, 3. So my new coordinates would be -1, -5. From here, I can also rotate in a negative direction. So what that means is if they're telling you a rotation of -90, it means instead of going to the left, I'm going to the right. So I would turn it to the right one turn. So 2, -3 would be at -3, -2. Because again, you look at the new orientation of the graph. Rotation of -90 would also be the same as a normal rotation of 270, but you can do it whichever way makes the most sense to you. Now, number 5, the stuff we've done so far is the basic stuff. That's what we're going to start with. This question number 5, is doing a rotation about a different point. So rather than everything we've been doing right now has been centered at the origin, but now we're being centered at a different point, 2, -2. So you're still going to do the same process, but you need this other point because that's now like your new origin. So, you know, you were like, this is like -1 from the new origin, if you want to call it that. So we turn our paper to the left. So now, instead of being down 1, left 1, you're right 1, down 1. Okay, and it's a little bit tricky because then you kind of just count that direction. So again, you just say, okay, so I'm down 1, right 1 from my original center. So then you flip your paper back over and you go in that direction. And that's how you deal with these ones. So you would be at 3, -3. I will go over this again, definitely the day that we practice this, but you might want to rewind this and watch this part again. It's not too tricky, but you definitely need to make sure you get it. All right, so again, I have a different center. It's 0, 1. I turn my paper twice, and then I say, okay, I am now down 1 and to the right 3 from that center. So I turn my paper back around, I go down 1, right 3, and my new point is 3, 0 when I rotate it around that point. Reflections. To find the image of a reflection, you just flip it. You guys know how to do this. You just count. So if I'm under the x-axis, I'm going to go above the x-axis. So what's actually changing is my y value. My y value becomes negative or positive depending on what it was. If I reflect over the y-axis, I'm flipping that way. So my x value is actually changing. Okay, these two you should remember. The line y equals x is this purple dotted line. So when you reflect, you're actually reflecting across a diagonal line. That can get tricky for some people. So what's going to happen is that your y value and your x value are always going to switch. The value of the line y equals -x is the purple dotted line. And again, you're reflecting over a diagonal line. But this will always happen. They will switch and they will become negative. My highly big suggestion to you is you memorize those two because it's very difficult to graph those lines, remember those lines, and then remember how to reflect over those lines. So I really encourage you to memorize those two. But the rest you can just do, or if you're a rule person, remember your rules. Okay, so let's do a few examples. If I have the point 3, -2, and I reflect it over the x-axis, I literally just count up 2 from it, and then I go 2 more. You guys are really good at this. You're fine. So that's 3, 2. My y-axis, I'm going to go over my y-axis, so I'm now at +1, -4. And y equals x, I'm going to switch the signs. So again, I would be going in a diagonal direction, but I'm just going to switch my coordinates, so -3, 2. And then to reflect over y equals -x, I'm technically reflecting diagonally, but I would just switch and negate the numbers. 0 can't become negative, so it just stays 0, but the 4 becomes negative because it was positive. And then I can reflect over something other than those lines. So if I wanted to reflect over the line x equals 3, I first have to graph that line. This is the line x equals 3 because it crosses the x-axis at 3. And then I do the same thing. I just count to that line and away from that line. So my new point would be 1, 1. Again, here y equals -2 is this line here. Now, in this case, my point is on that line. So it's actually still going to be the same thing because I can't go up or down if I'm on the line. It's an invariant point. That is it for this video. You might want to rewind and watch some parts, but that's the gist. Have a wonderful day, and I will see you in class.